Hi students, today we are going to discuss some numerical problems related with the chapter motion. Before going to that problem, we can just have a look at the concept of motion, distance and displacement. A common characteristic of all the moving bodies is that they change their position with respect to time. Here you can see that the body is changing its position continuously from A to G. So a body is said to be in motion. With respect to time, it's changing its position. Here you can look at a stationary object. At the same time, the body is changing position with respect to that stationary object. Here, A, B, C are different positions from that stationary object. So this body is continuously changing its position. But we studied that if a car is moving like this, those who are sitting inside the car, they are stationary to each other. From outside a point here, we can see that that body is continuously moving from A to G with respect to a stationary position. Let us look at another case. A man wants to travel from A to C. His first position is A. Suppose he moves along this straight path towards the position C. So let it be 5 kilometers. But if this person wants to take another route, just like A to B and from B to C. So now we can see that the path is different. Let A to B is 2 kilometers and B to C is 4 kilometers. Then the total distance covered by this body is 2 kilometers plus 4 kilometers, that is 6. But the straight path is between A to C, that is 5 kilometers. So this is the concept of distance and displacement. A, B, C. From A to B and B to C, we call it as the total distance covered. A to C is the shortest path, which is the displacement. An ant travels a distance of 24 centimeters from A to B and then moves a distance of 7 centimeters right angle to AB. Find the resultant displacement and the total distance covered by it. This is the question. So this question is related with the distance and displacement. Let this be the path of the ant. First it is travel straight and then a 90 degrees. We can mark it as A, B and C. A to B and then B to C. So the distance from A to B is 24 centimeters and B to C is 7 centimeters. First we want to calculate the total distance. That's easy because total distance covered is the actual path covered by the body. That's the distance from A to B and B to C. A to B is 24 centimeters and B to C is 7 centimeters. So total is 24 centimeters plus 7 centimeters, that is 31 centimeters. That's the answer for the first part. Now the second part is displacement. You must have an idea about displacement. So it is the shortest distance from the initial point and the final point. Here A is the initial point and C is the final point. So the distance between C and A. So distance from C to A is a straight line. Now look at the triangle ABC. Here AC is the hypotenuse of the right angle triangle ABC. Here B is 90 degrees, AB is 24 and BC is 7. We want to find AC. This is 90 degrees. According to Pythagoras theorem, you know that AB square plus BC square is equal to AC square. Here we know AB, BC, AB is equal to 24 and BC is equal to 7. So if you want to find out AC, we have to square root AB square plus BC square, or square root of 24 square plus 7 square. That is equal to root of 625, and that is equal to 25 centimeters. So that's the answer for the second part. So the first part, total distance covered is equal to 31 centimeters and displacement is equal to 25 centimeters. Hope you understood this problem. We can move to our next question. Find the displacement of the tip of an hour hand of the clock between 12 p.m. and 3 p.m. when the length of the hour hand is 7 centimeters. Let it be the hour hand. Now we can slowly move this hour hand towards 3. Now 12 to 3, the movement. You can see that the angle is gradually increasing. And the actual distance, actual path from the tip of the first position to tip of the second position is a curve. Displacement is from B to A. That's a straight line from the finishing point to the starting one, the straight distance. Now OA and OB are the radii of this quadrant, that is 1/4 of this circle. Now we can check the displacement AB. How we can find AB? That we already discussed according to Pythagoras theorem. Here AB square is equal to 7 square plus 7 square, or AB is equal to root of OA square plus OB square. So here OA is equal to 7, OB is equal to 7. So 7 square plus 7 square, that's 49 plus 49. That's equal to 98, root of 98. If you factorize that, you will get this answer as 7 root 2. So 7 root 2 is the displacement between A and B from the final position to initial position. If we want to find the actual path covered by the tip of this hour hand, we have to consider the total circle here. Now you just consider ACB. This ACB is the part of a circle. That means it's the 1/4 of the circumference of that circle. So you know the formula for circumference is 2 pi r. So it is 2 pi r divided by 4. So 2 into 22 by 7 into 7 divided by 4. So at that time, you can cancel 7 and 7. After dividing, you will get it as 11 centimeter. So the distance covered by the tip of the hour hand is 11 centimeters. I hope you enjoyed this class.